In this section, we're going to be translating verbal phrases into equations or inequalities, which is building off of already having done it for expressions. And then the other thing we're going to do is decide if a given value is a solution to an equation or an inequality. So an open sentence is not something you're going to hear about very often, but essentially all it is a math sentence that either has an equal sign or an inequality sign. And essentially what it does is it compares two expressions. It just basically means you're going to have two sides. So you could have an expression on this side and then an expression on this side, and in the middle you're either going to have an equal sign or an inequality sign. There's just going to be two sides. We already know that an expression, the important thing that we talked about was, other than that it has a number, a variable, and an operation, it does not have an equal sign. So here's where this new language comes in. If it's an equation, it's just going to be an open sentence with an equal sign. So we talked about an expression doesn't have an equal sign. So if you see something without an equal sign, you'd call it an expression. If you see something with an equal sign, you call it an equation. And if you see something with an inequality sign, obviously you call it an inequality. So essentially you can have one of three things. You can have an expression, it doesn't have anything. You can have an equation, it has an equal sign, or you can have an inequality, it has an inequality sign. And then just like expressions have keywords and phrases that indicate what operation you want to do, like sum meant to add and difference meant to subtract. Similar here, there's certain keywords and phrases that mean to put one of these symbols. And the biggest indicator that you're going to have either an equation or an inequality, it works for both, is that you have the word is. So if you see the word is, you're going to have two sides. Now, if it's all by itself, not followed by anything else, is all alone, it means equals. Some other things that are really obvious, but we'll say them anyway. If you see is the same as, that would mean an equal sign, or even more obvious, is equal to. But is the big one. That's what you're looking for. If you see the word is, it means you have an open sentence. You have two sides. So your four inequalities here, we have the basic language for those. This first one is less than, and the next one is greater than. And again, that word is super important, because if you just saw less than all by itself with no is, we already know that less than means to subtract. So it only means to put this symbol if you actually have the is as part of it. Is less than, is greater than. And then here we have the same symbols, but because of the line on the bottom, it just means or equal to. So is greater than or equal to, is less than or equal to. Now these two also have some other language that's a little more common in the real world, and it's called at most, at least language. So if you think about something practically, like a math test, at most what you could get on a math test is 100. So what that means is at the most you could get 100, so you could get 100 or less. So less than or equal to would also be indicated by the words at most, because at the most, at the very highest, means that number or less. And this would be at least, because let's say you wanted to make at least $50, you'd want to make $50 or more. So at least would mean greater than or equal to, at most would mean less than or equal to. So for this first example, what I'm going to go through, it says translate the following phrases into equations or inequalities. So the first thing is, it's not asking if it's an equation or an inequality, it's just asking me to translate, basically make a math sentence, just like I did in the previous section. So I'm going to underline my keywords and phrases as I see them. And again, if I hit a second keyword or phrase, I'm going to use parentheses, because that would indicate grouping. So the first keyword or phrase that I see is difference, and I know that that means to subtract. So I'm going to put my subtraction symbol. And then I see my second keyword or phrase, which is twice. And because difference doesn't change the order of subtraction, my twicing, it sounds kind of funny, is going to go here. And I know that means twice means to multiply by 2. And the thing that's being twiced is the number k. So twice k. Also, it was my second keyword or phrase, so that means I should use parentheses. Then I get to just and 8. So it's the difference, subtraction, twice k and 8. So my 8 just comes after the subtraction. The next keyword or phrase that I see is tiny but important. It's the word is. There's nothing else. So that means it's just equals and then 12. So 2k minus 8 equals 12. If you leave the parentheses, I'm totally fine with it. Once you see that with or without the parentheses, order of operations says you would do multiplication before subtraction anyway, you're allowed to get rid of them. But you're only allowed to get rid of the parentheses if it doesn't change the order that you do things. Here you would do 2k first because it's in parentheses. Here you would do 2k first because multiplication comes before subtraction anyway. I would take either answer. The safe bet is anytime you see a second keyword or phrase, you use parentheses to make sure you're getting the order correct. You're going to try the next 3 examples. I would underline keywords and phrases as you go. Use up here the language that we just talked about, especially for at most, at least, if needed. Press play when you're ready to check your answers. So in this first example, I have product, which means multiply. I'm multiplying 6 and a number, and it didn't tell me what the number was, so I just made up n for that. And then is at least 24. I should have underlined the is as well. Is at least 24 means that it can be 24 or more. So is at least means 24 or more, which means greater than or equal to. Quotient means to divide, and remember we're going to show division by using the fraction bar. I'm dividing p in 12, so p over 12, and again, is at least 30 is greater than or equal to 30. Down here, sum means to add, twice means to multiply by 2, and it's twice r. And since twice was my second keyword or phrase, it gets put in parentheses. And then 3 is the other number that's part of the sum. Is all by itself, which means equals, and equals 11. In this problem, you'd multiply 2 and r before you add because it's in parentheses. But even if the parentheses weren't there, you would multiply 2 and r before you add because multiplication comes before addition. So this is an example where it's okay to drop the parentheses, but I would take either one. Try these 2 examples, pause the video, press play when you're ready to check your answers. So in the first example, we have quotient, which means to divide, a number in 2. I don't know the numbers, so I just used x. And then is at most 16. At the most 16 means it could be 16 or less, so less than or equal to. Your math grade, which we're calling G, needs to be at least a 75. So if you think about, like, if your mom said that to you and said you need to get at least a 75 or you can't go out this weekend, that would mean that you need a 75 or more. So G is greater than or equal to 75. So these next few examples are going to combine some inequalities, and so we'll do some work with explain everything to show how that's going to work. So the first thing that we see is that x is greater than 3. So I'm just going to make an inequality out of that. So that one's pretty easy. X is greater than 3. Then I'm going to use blue to show that x is less than 9. And I'm going to make an inequality out of that. So that's pretty easy. That's my second inequality. Here's the trick. I want to, instead of having 2 separate inequalities, both having x, I want to have one nice inequality just having x. So what I'm going to do is I'm going to try to get my x's to overlap, but not my numbers. So right now, if I drag the red on top of the blue, x is on top of x, but 3 is on top of 9, which isn't what I want. So in order to do this, what I'm going to do is I'm going to flip my x backwards. It looks a little funny. And then I'm going to drag it on top. So now I have my x's on top of x's, and again, I reversed it so it looks funny. And now I have the way it would look on a number line, which is if you go left to right, 3 would come first, and then 9 would come second. So the way that you would write this final answer, if I do it in pen, is you'd have 3 is less than x, which is less than 9. That's how we're going to write that. And then you can check it by reading it starting with x both ways. So the easy way to read it first is to read it x is less than 9, which was what the blue one had originally said. And then you can read it with x going this way, which says x is greater than 3, which, if you remember, was what this inequality originally said. So for this one, I'd start by saying a number y is no less than 5. So no less than 5. That would mean that y can be 5 or more, because it can't be less than 5. So it can be 5 or more. It can't be less. And that would look like this. Y is greater than or equal to 5. And then you have y is no more than 13. And so that would mean that no more than 13 means 13 or less, because it can't be more than. So we have these two inequalities right here, and then I want to write them as one inequality. So again, I'm going to start by putting my y in the middle, and I'm going to do it as I would see it on a number line. So on a number line, 13 would be farthest to the right and have less than or equal to, and the 5 would be over here. Now I just want to make sure that I put the right inequality separating 5 and y, and so if I look at this inequality, I can either turn it around, and you can see that it kind of says 5 is less than or equal to y, so we'll put that in. Or I could keep it the way that it was, but read it. If I read it with y, it says y is greater than or equal to 5, and now if I read it this way, it says y is greater than or equal to 5. Pointy side faces the 5, pointy side faces the 5, open side faces the y, open side faces the y. So this is my compound inequality. Pause the video, try this example right here involving q. Make sure that your answer in the end kind of goes in order from left to right, smallest to biggest. Play the video when you're ready to check your answer. So here you have q is at least 5, so q is greater than or equal to 5, and q is less than 17, so here are your two separate inequalities. So the one that you keep the same is that q is less than 17, and then here if you read this out loud it says q is greater than or equal to 5, and this way it would say q is greater than or equal to 5. The next part deals with solutions to equations or inequalities. So again, the first thing we want to decide is a number a solution. So to do that, the definition is the value of the variable that makes the statement true. Basically, you plug in a number and see if it works, and if it works, then yes, it is a solution, and if it doesn't, then no, it's not. So these four examples down here, what we're checking is 3 a solution to the equation or the inequality? And your final answer is going to be yes or no. Be careful, it's not asking if it's an equation or an inequality, it's assuming that you would know that the two with equal signs are equations and the two with inequality signs are inequalities. A lot of people write these as their answer, but the answer is a yes or no question. It's asking yes or no, is 3 a solution or not? So you're going to plug that in. So it's really simple. You just rewrite your equation or inequality, but you take out your variable and you put in your value. In this case it's 3. You follow order of operations, and you just keep going until you see if it works or not. And in this case it did work because 2 equals 2, so your answer would be yes, it is a solution. If I do the one below, again this time I'd replace z with 3, and I do out the math and see if it's greater than 12, and I end up with 11 is greater than 12, which it's not, so no, it is not a solution. Pause the video, try these two right here. If you're still checking if it's 3 is a solution or not, final answer should be yes or no. Press play when you're ready to check your answers. So for the first example, 4 times 3 is 12, 12 minus 5 is 7, and 7 doesn't equal 6, so no, it's not a solution. 3 times 3 is 9, 9 plus 5 is 14. 14 is less than or equal to 20. It's not equal to, but it's less than, and it's either or, so that's a yes. Keep in mind that on a test or a quiz, in order to receive full credit for this type of problem, you're going to need to show all of the work involved. You can't just answer yes or no, otherwise it's just 50-50. It wouldn't explain your thinking. And whatever's on the right-hand side of the equation or inequality, like equals 6, less than or equal to 20, equals 2, greater than 12, you should be keeping that side the same the entire time. For these 4 examples right here, if you want more practice, pause the video and press play when you're ready to check your answers. If you feel like the previous 4 examples were plenty, then put a star and a smiley face as a symbol that you were good and didn't need any extra practice. Otherwise, pause the video, press play when you're ready to check your answers. Just some general reminders why you're doing problems like these. The first thing is that it's a yes or no question, so either yes or no should be your final answer, not the words equation or inequality. And while you're working, don't forget to follow order of operations and ensure that you always have a number on both sides of your equal sign or your inequality sign. Here are your 4 answers and the work that goes along with them. Down here, there's 3 additional examples, very similar to what we've done, they just look a little bit different. So it says check whether the given number is a solution. So up here, they gave you the same number in all 4 problems. Here, they're giving you a different number each time, and the number that they're giving you to check comes after the semicolon. So here, your equation is 9 minus x equals 4, and you're checking the number 5. So it's as simple as before. You replace x with 5 and see if it works, which in this case it does, so you would say yes. Just to make sure you can follow this format, pause the video, try the additional 2 examples, press play when you're ready to check your answers. So on this first example, we're checking the number 7, so b gets replaced with 7. 7 plus 5 is 12, which is less than 15, so that's a yes. Here we're checking the number 9. 2 times 9 is 18, plus 3 is 21, which is greater than or equal to 21. It's not greater than, but it's equal to, so that's fine, and that would be a yes. So now we're going to get into word problems. So the first thing that you want to identify is what's the unknown quantity and assign a variable to that. So in this problem it says the last time you and 3 friends went to a mountain bike park, you had a coupon for $10 off the total purchase. So you know you're going to be subtracting 10 at some point. And you paid $17, so it equaled $17, and you bought 4 tickets. The first thing that they're asking us to find is what the regular price of the 4 tickets should have been. What's the regular price? And you paid $17, but you got $10 off. So if you work backwards, you know that you should have paid an additional $10, so it should have been $27 for the 4 tickets. And then it asks what's the price of 1 ticket. Well, it was $27 for 4, so we can just divide 27 by 4, which is basically making it a unit rate, which gives us $6.75 for 1 ticket. Another way to do this problem would be to assign the variable x as the price of 1 ticket. And we know that we were buying 4 of them, so it would be 4 times the price of 1 ticket. And we got $10 off the total price and paid $17. And now we could solve this as a multi-step equation, which we actually won't review until chapter 3, so I won't go through the process now, but if you know how to do that, you could do that. So pause the video and try these 2 problems. Try to start by setting up some type of an equation or an inequality, which means you want to identify a variable. You can also do it by working backwards or guess and check, but pause the video. When you're ready, press play to check your answers. So on the first example, the main thing actually is that they want to beat last year's total, which is 351. So first you want your point total to be greater than 351, not greater than or equal to. And they tell us that they're playing 18 games with an average of 20 points per game. So 18 times 20 would be 360 points, which does beat his last year's total, so that's fine. You could also set it up like an inequality, but you just have to assume one of them is unknown. So maybe you know that they're playing 18 games but don't know how many points. But again, either way would be fine to solve it at this point. And down here, he wants to make no less than $610, so that means he wants to make 610 or more, because he doesn't want to make less than that. So greater than or equal to 610. He's selling 28 mugs for $22, which would be a total of $616, which would be enough to achieve his goal. And again, you could set it up as an inequality and then replace, but for now you have all the information, so that's perfect.